My name is Obatel, and I will be discussing our lab report 1 over constant velocity. First, a table of contents. We will first have an introduction. Next, the experiment of constant velocity with its comparison to the computational model. Then lastly, we will have a discussion with some additional further questions. Before I begin, we need to first understand key concepts regarding this lab. Firstly, we have Newton's first law, which states that an object will stay at rest unless acted upon another object. In order for there to be constant velocity, it must adhere to Newton's first law, meaning that there is no net force and the change in position over time is constant throughout the object's motion. We will also be using the position update formula, which uses the object's initial position as well as its average velocity multiplied by the change over time in order to update the final position of an object. The average velocity will be equal to the initial velocity since the object is in a state of constant velocity. We'll also use the velocity update formula, which similarly has an initial velocity with the net force being multiplied and divided by change over time and mass respectively, which updates the object's final velocity. Next, the purpose of this lab is to demonstrate the idea of constant velocity. We will determine this by using a video editing system known as Tracker that measures the motion of an object in a state of constant velocity. In this case, the object is a standard women's basketball. We will then compare this to a computational model of what the motion is supposed to be and deduce our conclusions from that model. Also, since we are trying to verify the object is in constant velocity, we can assume that net force is equal to 0 or that there is no air resistance or friction. The system is the basketball and the surroundings is everything else, such as the carpet or cabinets. The diagram below shows how initially there was an applied force in order to get the object to start moving. However, after some time, the object should remain in a state of constant velocity, resulting in the only forces acting on the object being the normal force and gravity, which cancel each other out. This is the tracker video. The graph shows the position time graph for the basketball motion. Since the basketball is moving from the right to left, the y-axis is negative, resulting in a negative slope graph. Here are some important data that will be used to produce the computational model. The diameter of the basketball is 0.234 meters. The mass is 0.54 kilograms. The start time is 0 seconds, while the end time is 0.667 seconds, meaning that the change over time is the same as the end time. The ball initial position is also shown at time equals 0, and the ball initial velocity was calculated using the calculations below. Next, we coded our findings in Python using a website called GlowScript. This snippet of code attached shows the basketball mass and its initial position and velocity, which were stated in the previous slide. Delta T is equal to 1 over 30 since the video was recorded in 30 FPS, meaning that every 30th frame the object motion was being recorded. Next, the while loop, which updates the position of the object's position and velocity using both the formulas mentioned in the beginning slides. As you can see, since the object is in constant velocity, the fnet vector is equal to 0, and the code to update the ball velocity and position are listed below, here and here. Now, notice how similar these codes look to the formulas below, here and here. Then delta t is added again to t until the time reached the value of the final observation time, that being 0.667 seconds. These are the results from GlowScript. This is a graph for the observed motion of the basketball versus the predicted motion of the basketball in a position time graph. Since the object was moving right to left, the graph will be sloped downwards with the x-axis being time in seconds and the y-axis being position in meters. As a result, the velocity in the beginning appeared to be the same, which indicated that there was no true net force being applied to the object. However, towards the end, the lines deviated from one another, meaning that there was actually some force moving in the opposite direction, resulting in the basketball slowing down. Some possible errors include the tracker center of mass being miscalculated or just simple rounding errors. Some further questions that may be asked is, what if the axes were flipped? That would simply make the graph flip, resulting in a positive slope graph instead of a negative one. The magnitudes of all the position and velocity would still stay the same. Also, some may ask if it is possible to determine how many forces are added together to give a zero net force. The answer to that is no, because it is possible to observe what forces would go against the object motion. And again, trying to observe air friction, air resistance as forces would be quite difficult to observe. Thank you for your time.